In this video, I want to look at two problems composing sine and cosine inverse. So let's take a look at the first one. Sine of the cosine inverse of a positive 4/5. 4/5 is not a cosine value for one of the special points on the unit circle, so I'm going to have to use triangles to compute this, or to evaluate this expression. So let's go ahead and draw the coordinate plane. Cosine inverse, right, spits out an angle between 0 and pi. So I'm going to use a triangle somewhere in the upper half of the plane. And knowing that my cosine value is going to be a positive 4/5, I'm going to want to use a triangle in quadrant 1. So here is my reference triangle. I get a cosine value of 4/5, so I'm going to use 4 for the adjacent leg and 5 for the hypotenuse. By the Pythagorean theorem, that makes the opposite leg length 3. So the sine of this angle, whatever this angle happens to be, is going to be positive because it is in quadrant 1, and it's going to be a positive 3/5. What about the second problem? Sine a cosine inverse of a negative 4/5, right? Well, again, cosine inverse spits out an angle between 0 and pi, so we'll want to use a reference triangle somewhere in the upper half of the plane. For cosine to have a negative value in the upper half, it must be a rotation that brings me into quadrant 2. So I'm going to use a reference triangle in quadrant 2. We're getting a cosine value of negative 4/5, so the length of the adjacent I will make 4, the hypotenuse I will make 5. By the Pythagorean theorem, that opposite leg from my reference angle is going to have length 3. So the sine value of the rotation that brought us into quadrant 2 is going to be a positive 3/5, right? Positive because sine is positive in quadrant 2. So what do we notice? We notice that in either case, whether or not cosine inverse spits out an angle between 0 and pi over 2, or one that lands between pi over 2 and pi, the sine value is going to be positive, right? And in fact, there is a general formula for this composition. The sine of cosine inverse of x, x being a value between negative 1 and 1, is always going to be the square root of 1 minus x squared. And kind of a short, quick proof of that, think about the cosine inverse of x. If x is a positive number, if x is positive, then we're going to put a triangle in quadrant 1. If x happens to be negative, we're going to throw a triangle into quadrant 2. In both cases, by the Pythagorean theorem, the opposite leg has length 1 minus x squared. So in both cases, since sine is positive in quadrant 1 and quadrant 2, the sine of the angle that gives me these triangles is always going to be the square root of 1 minus x squared over 1, which is just the square root of 1 minus x squared.